All morning, you have been treated to the expertise and knowledge of Mr. Pinnock, our keynote presenter. Let me briefly give you a little background on Mr. Pinnock. He has had more than 25 years of teaching mathematics. He holds a MSc in Applied Mathematics and Marine Engineering. Currently, he's a lecturer at the University of Technology, and he's pursuing a PhD in mathematics and adult education at Walden University in the States. It is with pleasure that I welcome Mr. Pinnock once more to the floor.
Okay. So, as the name applies, pedagogy for the transition of mathematics continuity. I want us to be lifelong learners, non-stop. What is the meaning of pedagogy? Yeah, it is the science of teaching. And so, teaching is not just a cognitive skill, but it's a mixture of social and cognitive abilities. In other words, my education theory is encompassed by social cognitive orientation. All right, so we will go through the slides. We are now looking at radicals. What is a radical quantity in mathematics? Example root A. Now, how is that going to be applicable to your working environment? You can use that to do rationalization. You all know about that, right? Hello? Yeah, you can use that for rationalization. And a typical CAPE question for 4 marks would have been, can somebody tell me what would be a typical CAPE question for 4 marks in terms of rationalization? Five plus what? Okay, and in order to rationalize that, what would you do? You try to let the denominator be a real number without a root. And so you would multiply the denominator by what we call the conjugate surd. And the conjugate is nothing but similar expression with a change of sign in the middle. What is important about that change of sign, it goes back to a minus b times a plus b when being expanded difference of 2 squares. Some people wonder, why is it the math is so hard to do? You'll have to know what to do. So if you have, for instance, 2 plus root 3 times 2 minus root 3, that is just what? 2 square minus root 3 square, which is 4 minus 3, 1. The denominator happens to be 1. Notice, we are now calling on the CXC knowledge of what? Difference of what? Difference of 2 squares. So when you're lecturing, these points must be made clear to your students. All right? Because we're taking the fifth form knowledge onwards. Okay, very good. We move on to factor for algebraic expression. X squared minus y squared is a very important expression because we use that up very, very often. In fact, we had just used it a while ago, right? What would be the factors for 1 minus a squared? You know, how many persons at times cannot appreciate that 1 is really 1 square? So what I normally do is to write it in the difference of 2 square form. So even though it is 1, I write below that 1 square minus a square. Clearly, that is 1 plus a, 1 minus a. All right? So we're moving on. If that is the case, I learned about x squared minus y squared. So what about x squared plus y squared? That can only be written as an expression. X squared plus y squared is what? X plus y all squared minus 2xy. You are going to need that when you go to quadratic theory, because x plus y represents the sum minus 2xy, the xy component represents the product. You cannot do quadratic theory not appreciating the sum of roots and the product of roots. Okay. So we're moving on. So if we know an expression for x squared minus y squared, hey, what about x cubed minus y cubed? What about the difference of the cube of 2 terms? It is important. You might not get, well, the factors are going to be what? X minus y into x squared plus xy plus y squared. Those must be known because you're going to use those as tools. Hello. What would be b cubed minus r cubed? Can anyone give me those factors? B minus r in one bracket, yeah? Right. You have to look at the first and the last term because those will give you the cubic expression. So, what about a to the 4th power minus b to the 4th power? Yeah, you can rewrite that as the difference of 2 squares. Yeah, so that's a squared all squared minus b squared all squared, which is a squared minus b squared into a squared plus b squared. A squared minus b squared is a minus b into a plus b, and a squared plus b squared is a plus b all squared minus 2ab. Right away you have some product. Some product is very important for your development. And last but not least, what about a to the 6th power minus b to the 6th power? Because it's continuity now. We could move from the CXC scenario, which is x squared minus y squared, go right up, but we're stopping at a certain point. The last one is a to the 6th power minus b to the 6th power. Factors. Yeah. 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 So that, thank you, Mr. Gordon. That mathematical tool is very important for students to do what? Sum and product of roots. That is coming in the CAPE examination. So you'll have to train them so they can deliver. All right. So we move to the Pascal Triangle and binomial expressions. You know, when I was a little boy growing up, and I got a plus b all squared. In fact, for 5 years I've been in the exile, leaving my son in Clarendon to operate the mathematical institution that I have developed. His name is Pinnock. When people see us, they say, but he's a brother. But I started out very early. So he's representing Math Supreme, and he's doing a wonderful job. The last time I checked the records at the overseas office, he's ranging from 94 to 98% passes in CXC maths every year, both January and June examination. Let us give Rowan Pinnock Jr. a round of applause for that. So even though I'm not there most times in the physical, I am there in the spiritual, because I give them spiritual guidance, I am not the creator, but we are connected like that, and bloodline.